5.8, I'm going to go over 5.8 is actually really short. It's actually a good time to do it now, because before you forget about those formula. So I'm going to share the screen over here. Okay, all right. Okay, let's do it together, okay? Do you guys have the note for 5.8? Okay, okay, you got it, good, okay. Okay, so we have learned all this factoring. So today we're going to summarize all this, all those methods. Okay, so we'll put them in a two-step strategy. Okay, factoring strategy. Okay, so there are only two steps. Okay, so the first step is to put that in the right order and take out greatest common factor. Okay, so what do we mean the right order? So if you have x, you order them from the highest exponent to the lowest exponent. Okay, highest power of x to the lowest power of x. Okay, in this order. If a and b, you order them this way: a squared, ab, and b squared. Okay, and then you take out the greatest common factor. So that's the first step to do. Don't forget. Okay. Now the second step is to see how many terms. Suppose it has 4 terms. Anybody remember? If it has 4 terms, what kind of method to factor? Anyone? Let me look at the chat. What kind of method if you have 4 terms? Have to take out GCF. How about we group this 2 and group this 2? It's called the grouping method. Okay. So you have 4 terms, and we'll try the grouping method. Okay. So later I'm going to give we'll do one example to refresh your memory on the grouping method. Okay. So group the first 2, group this last 2, take out common factor from the first group, take out common factor from the second group, and if you see the same expression happen in the in this 2, then we take out that common factor and either put it in front or at the end. Okay. Okay, so that was 4 terms. Think about the grouping method. Okay. So if it's 3 terms, okay, if it has 3 terms and it's in the Y form, like one of this form right here, okay, if the 3 terms are in this form, one of this form, then what kind of method? Start with a T. So we use the try and error method, right? So try and error method. Sometimes we call it try and check method. So try and check method or try and error method. Okay. Sometimes we use perfect square formula to factor that. Okay. So the perfect square formula is like this, right? Now I gave you one example to refresh try error and perfect square. Okay. Now this one here is a trinomial in the form of this x squared, x and number. So if I use try error method to factor this, I factor this x squared into x times x. Think about 2 numbers, multiply to get to this number, and sum up to the coefficient for this middle chain, x chain over here in the middle. Okay, so I try x. I try 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. So plus 3 plus 3. So now, because these 2 factors are the same, we need to unite them, okay? So we unite them, we put down as a square of x plus 3. So it is actually a perfect square, okay? So that's using try error. But sometimes, if you can recognize it, it's actually a perfect square. And how do you recognize perfect square? So when you have 3 chains like this, the first one here, if you can write it as a square, the last one here, if you can write it as a square, then you check the middle one. So you use 2 times the base for the first and the base for the last. And if you happen to match with this chain in the middle, then it is a perfect square. It is a perfect square of, well, you take the base over here, and then the sign here is addition, so addition, and you take the base over here, which is 3. So it's a perfect square of x plus 3. Okay, so for 3 chains, think about maybe we can use try and error or perfect square, okay, to factor that. Now, what about 2 chains? Today we learn about 2 chains. Today we learn about difference of 2 square, sum of 2q, and difference of 2q. We also learn about sum of 2 square also. So we learn about this today. Out of these 4 cases, one of them, after taking out greatest common factor, one of them is a prime polynomial, cannot be factored by real number. So what are they? What is that one? Which one is prime? Can someone tell me? Oh, sum of 2 square. Oh, you're fast. Okay. Well, you type really fast. Okay. So sum of 2 square here, it is a prime polynomial. So this one is prime. And the rest of them are not prime. They can be factored. Okay. Sum of 2 square. So what does this one here factor into? It factor into 2 factor. Okay. Actually, there's a similarity between all this. The first factor for the rest over here, all of follow the same pattern. You just ignore the square here. So you get a minus b. Okay. And over here, you ignore the q here. Then you have this a plus b. So the first factor, and this is a minus b. Okay. Just take away the q right here. Okay. So the first, all of them, the first factor will have the same pattern. Okay. The second factor for this one here will be the difference of 2 square. The second factor, you just change the difference here into sum. So we'll have a plus b. Oh, I'll share again. Okay. So for this one over here, the second factor will be long. It has 3 chains. This has 3 chains. Okay. For the sum of 2q and difference of 2q, the second factor will have 3 chains. Okay. They have the same pattern. A square, AB, B square, A square, AB, B square. Okay. And the side follow a cube or slope. Okay. So same side with this. Opposite side. So addition here will subtraction. So opposite side with this, so with subtraction. Opposite side with subtraction here, this will be addition. And the last one, always plus over here. Okay. So this is a factoring strategy. The main things is factoring is going to use over and over when you take higher math. So it's actually very important, you know how to do factoring. Okay. Okay, let's practice on this. Okay, so first that we take out greatest common factor. What's the greatest common factor of these 3? It is what? You see the 12, 2, 4, and then we have 2. It's greatest common factor. A squared, A, and no A, so we just have A here. And then B squared, BQ, and B squared, so we have B squared. It will be the variable to the lowest exponent that happened on that variable. So CQ, C squared, CQ, the lower exponent on C is 2. So we have C squared over here. So C squared over here. Okay. Oh, did I make a mistake? Do you guys catch my mistake? The A shouldn't be here. Okay. The A shouldn't be here. Okay, let me do this. the A shouldn't be here. Okay, because why? You see, this one has no A, right? So the A is not a common factor. Okay, 2b squared c squared. Yes, you got it. Okay, good job. Okay. Okay, now put it in here. So this will be, inside the parentheses, we'll have this 6a squared c minus ab minus 2c. Okay. And looks like inside here, I cannot factor this. This is not in a special form that you can use try and error. So that's it. That's the final answer here. Okay, the next one over here. Okay, so we take out the greatest common factor here. The greatest common factor here is what? 3 and 48. The greatest common factor is 3, right? Okay. Now this one doesn't have A, so A shouldn't be in the greatest common factor. Okay. What about B? This one doesn't have B, so no B in the common factor. C, CQ, right? Yeah, it says CQ. CQ. Yeah, you have CQ and CQ. So CQ is a common factor. So CQ here. Okay. Now after that, what should I put inside the parenthesis? Sixteen a to the 4 minus b to the 4. Okay. Let's copy the 3CQ outside. Now inside over here is a difference of 2 squared, right? Do you recognize the difference of 2 squared? Okay, remember this part over here. That's the difference of 2 squared. Okay, is 4a square minus b squared. It's a difference 2 squared. So we could factor this. Okay, so what will be the 2 factor? So the 2 factors over here. Okay, tell me what are the 2 factors. The first one will be take the base, subtract this base, right? So just 4a squared minus b squared, then 4a squared plus b squared. Okay. Okay. All right. So now we can continue to factor this, right? This one again is a different 2 squared. Okay. So we have this 3c cubed right here. Okay, we can continue to factor this. Okay, let's see. What do we get here? Okay. What does this factor into?
2a minus b.
Yes, we got it. Okay. So this one here is, this is the square of 2a. This is the square of b squared, right? This is the square of b squared. Okay. So it's a difference of 2 squared. Okay. So you have 2a and b, 2a and b. The first one will be minus, and the second one will be plus. Okay. Okay. The last one, the last factor over here is a prime polynomial. It's a sum of 2 squared, right? So this is this prime. So you just copy. So 4a squared plus b squared. Because this is the sum of 2 squared. It's prime. Okay. Okay. Now we are done. Oh yeah. The last one. We're done with this problem, but we still have a little bit. I feel like I'm torturing you guys, putting you on all this. Okay, but pretty soon, okay? Okay, so you don't need the last one right here, okay? Okay. Okay, the last one. Well, actually, may not be the last one, the second last one. Okay, so first we put it in the Y order, okay? So according to, this has x and y, so you order them from the highest power of x to the lower power of x. So you have this x to the 5th y, and then next one will be x cubed y cubed, and then x squared y to the 4, and then y to the 6. Okay. After that, you see the exponent on x. So, so exponent on x here from the highest exponent to lowest exponent. Okay, x to the 5th, x third, x squared. Now we take out GCF. Okay, what's the greatest common factor here?
X squared y.
Okay, this one doesn't have x, so yeah, so we cannot have x here in the common factor because this one doesn't have x, so it will be just y, right? Yeah, just y. Okay. Now after that, inside the parenthesis we have x to the 5th minus x cubed y squared plus x squared. Okay, now take a look of this inside. It has 4 terms. What kind of method do you factor this? Oh, yes, grouping. Yes. Okay, grouping. So we group these two together, right? And then we group these two together. Okay. So y2 outside. Okay, look at the first group, this first couple. What do they have in common? What's the greatest common factor of these two?
X cubed.
Yeah, you got it, x cubed. Okay, x cubed. And then we have this x squared minus y squared. Okay, the second group. Okay, what's the greatest common factor of the second couple?
Y cubed.
Y cubed.
Y cubed, you got it. Okay, good job. Okay, y cubed. And then you have this x squared minus y squared right here. Okay. Now remember the grouping. So the grouping. So we have y. So for the grouping method, the second step is to take out this. If you see the same expression happen here, x squared minus y squared right here, it is a common factor of this term and this term. So we're going to pull out this x squared minus y squared. You can put it in front or at the back. Okay. So x squared minus y squared, put it out. After that, you use the parenthesis to include this x cubed plus y cubed. Okay. Now we have this y. Okay. So x squared minus y squared, you can factor that, right? This is the difference of 2 squared. Okay, what does that factor into? Anyone?
X minus y and x plus y.
You got it. Okay, x minus y times x plus y. Okay, good job. Okay. Now what about this? This is the sum of 2 cubes. Okay, we factor into one short, one long factor. This one here, we cover the cube. So we have x plus y. The second one over here, we have x squared. That will be opposite sign with this one. So if this is addition, then this will be subtraction. Subtraction. Okay. And then xy. Finally, the last one over here is addition. Okay. It's always addition. And always plus at the end. And then y squared right here. Okay. Now, you think you might be done already. There's only one minor detail you need to pay attention. So these two are the same, right? These two factors are the same. When these two factors are the same, you want to unite them, okay? So unite them and write it as x plus y squared. And the rest will be the same. Okay. Use this. Okay. Okay, this is indeed the last one. Okay, sorry about this. Okay, can do it. Okay. Okay, this one I put it in the order. So m to the 4 first, and then m squared later, and 36 after. So highest to lowest exponent on m. And now there's no GCF, so that's it. And notice that this is m to the 4, m squared, and the last one number. So think about we can use try and error factoring. Okay. So you try error factoring. So we factor, remember last time we do that? So m to the 4 factor into what?
M squared.
Yes, m squared. Yeah, you got it. Okay, good job. So we have m squared times m squared, right? So m to the 4 over here factor into m squared times m squared. Okay. And then we think about two number. Okay. Can you think about two number? Multiply to be 36 and sum to negative 13. What are the two numbers? Oh, yes, you got it. Okay, thank you. So minus 9 minus 4. Okay, right here. You got it. Good job. Okay. So negative 4 times negative 9 is positive 36. So when this is positive here, the two will have the same sign, either both positive or both negative. Okay. So because I want to sum to negative right here, so both of them will be negative. Okay. So these two add up to negative 13. Okay. Good job. Now, if you look at this part here, it's a difference of 2 square because 9 over here, it is a square, right? So you can continue to factor this. This is m squared minus 3 squared. Okay, and this one again is also different 2 square, m squared minus 2 square. So we can continue to factor them. Okay, so what will be the factor for this? M squared minus 3 square. M minus 3 times what? M
Plus 3.
plus 3. Good. Similarly, this factor into m minus 2 times m plus 2. Okay, and now we're done, finally. Take a deep breath. I'm going to post this on Canvas. So, yeah, there's a lot, right? Okay. Thank you for putting this up with me. Okay. So, for Christmas, the theme. Maybe I'll give one extra credit if you have red and white. Okay. Okay, good. Okay, good.